Greetings everyone, my name is Skorik. I am 8th grade student at the number 24 Information Technology lesson in Nuremberg, Russia. I am a member of the Saha Junior Science Academy. Today I would like to tell you about my project, digital library based on the microcomputer Raspberry Pi. The high cost of paper books as well as the decrease in the number of available online resources distributing licensed books. Many other factors make the digital library hugely in demand. You can see the main goal of my work on the slide. To develop a digital library, the following hardware platform was selected: a single-board microcomputer Raspberry Pi 3B Plus, which has a built-in Wi-Fi adapter, Bluetooth Ethernet port, low-priced and with all the necessary technical specifications. Let's move to the creation. To get started, download the Raspbian operating system image on the official manufacturer website and create a bootable microSD card. We install the memory card into a single board microcomputer Raspberry Pi 3B Plus, connect the monitor to output data and work with the shell via the digital HDMI port, Ethernet cable and power supply via micro USB. We start the Raspbian operating system and configure the system files, configuring the Raspberry Pi network equipment to work after the software installation. Then it installs the software for raising the wireless access point, for raising to local web server, and for digital library to work correctly. Hostpd Apache 2 DHCP PHP7. We lift the wireless access point using hostpd and DHCP, launch and configure the web server using Apache 2 to write the software for the future reliability. We use HTML, CSS, JavaScript, PHP. HTML, CSS is using to create the visual part of the library. JS will be used to create interactive components. PHP is using for users' interaction with the server. The system is ready for use. Then to protect the Raspberry Pi microcomputer, I have designed a protect case, elements of which I printed on 3D printer from a thermoplastic polymer, polylactic acid, PLA. The slide shows the elements of the case. Let's move to the tests. To begin with, identify shortcomings of software implements in programming languages, with the connection of various libraries. Conclusion: as assembly on Apache 2 plus JS is optimal for creating a digital library. Next, we will define the use of the device in the Wi-Fi network. Conclusion: the optimal distance for working is the digital model of the supplier consumer library is a radius for 40 meters within which the signal levels doesn't fall below 50% of the maximum possible value. Now we'll determine the use of the device operating system in the Wi-Fi network with obstacles. The optimal distance for working in the digital model of the supplier customer library is a radius of 36 meters within which the signal level does not fall below 50%. The purpose of the next study is the depends of the data transfer rate in supplier customer mode on the number of users connected to the library. Conclusion: the transmission speed of this data is directly proportional to the number of users connected to the library. The data transfer rate for classroom if the peak load is 2.4 megabit per second. In close using the Apache 2 cross-platform software, the CSS external document description language, the HTML hypertext markup language, the JavaScript programming language, and the PHP programming language based on the microcomputer Raspberry Pi 3B Plus was created. A digital library with the ability to exchange data, the features of which are mobility and the ability to work from 5 volts to ampere. Thank you for your attention.